Well, hello everyone and welcome to this webcast on technology for the underground mines of the future and on future-proofing current mines and projects. I'm Richard Roberts, the Group Editor at Aspermont. I'll introduce my fellow panellists in a few moments, but we've carried a lot of coverage in recent years on our future mining content channel across our Mining Monthly, Mining Magazine and Mining Journal platforms on the major shift in mining stance on technology-led productivity and safety gains. These are happening at a time when we can see other trends developing and gathering speed. One of them, of course, is the industry's move underground. We can see new large-scale underground mine developments in Chile, in Indonesia, the DRC, Nevada, in Eastern Australia, and maybe soon again on Kalgoorlie's famous Golden Mile in Western Australia. We can see a continuing shift in mining deeper below the surface. As I mentioned, the discussion about technology-led productivity and safety gains in mining generally is getting louder and louder. Most company CEOs are saying publicly more often that information, communication and automation technologies are must-haves, not nice-to-haves, which is a big shift from the industry narrative of only 5 to 10 years ago. And if they're not investing in technologies already, or these technologies, they're certainly planning for them. No doubt technology is going to play a bigger part in helping mine owners combat cost pressures associated with deeper mines, lower grades, increased energy intensity, remoteness of new infrastructure. It's also got to offset longer project delivery times, climbing, regulatory compliance, and ESG-related costs. So I want to talk today to a couple of gentlemen who've been pretty much immersed in mining's technology transition for many years about game-changing technology. But it's worth just quickly focusing again on that surface to underground mining transition and understanding that while little technically has stood in the way of open pit mine owners leveraging the latest communication and IT and also automation technology to shift people away from any operating hazards and really change the way they utilise and manage high-cost capital assets. Underground, the story has certainly been a bit different. And boiled down, there are or have been latency issues around everything from transport to communication underground. Certainly without GPS and without line-of-sight visibility, it's been challenging for underground mines to replicate eyes and ears on the ground, underground where they're needed. And so the adoption of various technologies in the underground arena hasn't been happening at the same pace as on the surface. Back in the 1980s, after an explosion at a coal mine in central Queensland killed a number of people, an Australian company, MineSite Technologies, created a so-called through-the-rock communication technology, which was a world first. It was described as being like a Morse code system for underground mine communication. If we shift to what's happening now, new technology is really a key to speeding up the transfer of big productivity and safety gains from the surface to underground. MineSite Technology has been around for more than 30 years and now has more than 300 mining customers worldwide. Haydn Roberts, the CEO of MineSite Technologies, is a mining engineer who started his career in underground gold mines in South Africa. He spent time in different roles with Rio Tinto and has been in senior management positions with some of the world's leading mining equipment and technology companies. Haydn, it's great to be speaking with you again.
Yeah, great to see you all again.
Also on today's call, we have Mark Palmer, MineSite Technologies General Manager, Product Management and Marketing. Mark was at one of Australia's largest energy providers, Origin, for a number of years in various leadership roles and has been around the industry for a long time. Welcome, Mark.
Thank you very much. Thanks for having me.
Pleasure. Haydn, underground hard rock mining has no doubt come a long way since your time early in your career in South Africa. We've heard mine owners talk about lifting the lid off underground mines with the help of today's technology so they can see everything that's happening subsurface, preferably in real time without the usual latency. In your opinion, how far down the road would you say the industry is at the moment? What are the main challenges still for underground mine operators?
So I think, look, correctly sort of said, I started my career out in South Africa that was 1987. To be fair to underground mining, we've always, we share the same common vision or same goals as surface mining, which is to improve safety and productivity. That's very much in our mantra and our DNA. But from there, it diverges pretty quickly, right? In some ways, surface mining has had an easier route in some ways to adopting automation and technology, whereas in the underground space, as you rightly pointed out, we've sort of been in a much more tougher situation. The operating challenges are harder, the technical challenges are harder, and so I think back in '87 when I first started out, we were trying to automate underground in South Africa. We were bringing in LHDs, trackless mining, tele-remote, but we had no capability at that point to even track somebody on the ground or even talk to somebody on the ground. So we had to do all these projects, as you said, logistically was a nightmare to try and do that. I think as I moved through my 30 years in this industry, both in surface and underground mining, I've seen the surface side of mining meet those challenges, adopt GPS. So we adopted GPS in US borax, the first mine ever to adopt it for fleet management in 1994. We then adopted Wi-Fi in surface mining in 2001, when that was the first installation that occurred. If you look at underground mining, we've sort of lagged behind by 4 or 5 years behind that surface approach. And I think for me, the challenges in the underground space have been that line of sight, that you're in a GPS denied environment. You're in an environment where ruggedization is now really key. There's a lack of real estate on equipment, on people. So all of those technical challenges are really in your face. I think today, the technology has really advanced on the back of what we've seen on surface mining. That sort of helped us in some ways in the underground space. But I think importantly, we've adopted technology and made it fit for purpose for the underground. What I mean by that is we've adopted our platforms to be a single platform for voice communications, for tracking, for visualization. We've worked really hard on that over the last 30 years to create a single platform, because that's what we need in the underground space. We don't have the real estate or the space to have multiple systems or the resources. So very much, whilst we've lagged somewhat behind the surface mining side, I think technically that's now starting to come together where we can offer the underground customers in mining a platform that can meet their various needs that they need. And in particular, that goal of arriving at an automation and a smart mine.
And Haydn, MineSite Technologies is working these days with a lot of different mining companies across hard rock and coal, in block caves, sub-level caves, room and pillar type mines. There is change happening in the underground space across all these segments, from what I can see, albeit the speed varies. Depends on where you go in the world and the type of operator. What are some of the key drivers generally of significant change that maybe haven't been there in the past?
I think the fact that on the surface side, the OEMs have been successful in implementing automation into open pit mines has certainly opened people's eyes to where you can go with adopting technology and automating a mine. So that's been a clear success across a number of vendors and a number of mines. So I think that's definitely driving people's interest to adopt this into the underground space. And as I said, we've always had that desire to do it, but there were some technical challenges. So I think COVID has really focused our minds on the importance of having enough bandwidth underground, adopting IoT and digitalization strategies so that we can have a smart mine, so that our sensors, our video cameras are connected and we can operate in a remote way. So again, and in part, again, to the surface successes, remote operation centers, I think have become really key because of all those things. And so I think that's driving the change. I think from a personal perspective, the people that now work in mines really expect that they can go underground and communicate via voice, that they're going to be tracked, that they can have a smart device and remain connected, that they can have access to AI perhaps in the cloud to analyze some of the streams that are coming out of these sensors. So I think there's the new generation of miner expects those kind of things. And I think that's probably a very important part of what's driving this is the people expect this, expect to be connected, expected to be in a smart mine, so that we can face the challenges that we do face with mines getting deeper, grades getting lower, and those challenges sort of increasing as we go along.
Mark, Haydn mentioned COVID and the industry's increasing reliance on reliable communications and other infrastructure. Given the remote work factor has invariably always been there, I guess we should just zero in on the reliability and capability, really, or capacity. What does critical infrastructure look like to MineSight Technologies customers these days?
Yeah, well, I mean, I think the COVID point of things has really kind of focused people on the need to be able to communicate remotely, not in a face-to-face environment, and that's as a general business need. And when the technology fails you, it's pretty inconvenient. When you then move that to the underground, that failure moves from the inconvenient and moves into the critical. And that's why it's an overused term, but there's a big difference between being in that environment and sitting in the office. So I think generally for people, this need for communication platforms has really been brought to the fore. So from our perspective, I guess, when you look at critical infrastructure, this infrastructure delivers more than just one function. It's a platform that delivers many of the needs of the mine. And so when you look at it from the first principles, how do we make a secure platform? It needs to start with the basics. So power, for example, is a critical function. If your system has no power, then you have no system. So when we start with this approach for a critical system, we start with that. Then we have the backbone, and the backbone is a fiber-based backbone, which gives you good security. It gives you high data rates. And then we need to consider then how do we connect to that backbone and what connects to that backbone. So we've created an infrastructure that allows you to configure what your critical system looks like and how you put it in, and to actually design in a level of redundancy and security. And that system needs to be easy to expand and easy to connect to. When you look at the devices and the functionality that sits upon that platform, then you can start to see the scope of what that platform delivers. So, for example, we sort of talk about communication, but we also need to talk about tracking. We need to talk about data. We need to talk about voice communications. And all of those sort of fundamental functions sit on there, and the system needs to be able to support those in a reliable way. So the platform with this basic fiber, and then the extension of that fiber through access points, with the technology that we've introduced, which is a PoE-based technology, allows you to be able to roll out this technology through the mine and extend the functionality of that backbone. So it's very important that that system has that kind of architecture, which allows you to bring those kind of functionalities as required. In addition to that, of course, we need to be able to provide connectivity, because part of the fundamental design is if I can't connect to it, then there's not much point in having the system there. So we've introduced another level of connectivity using PoE+, which is a very sort of standard connectivity, power and data connectivity standard. And our infrastructure gives you opportunity to connect to that. So the increasing use of cameras, for example, in mines for monitoring is supported by this system. And because they're supported by this system, and it's not just around data, it's around power, then they become secure because of our architecture. I think that the other thing with this criticality is we talk about criticality in terms of reliability, but we also have a criticality in terms of the ability for that system to be able to adjust and adapt and grow with the mine. And so we need to remember that it's not there just to be a platform. It's there to enhance the safe and efficient operation of the mine. And so it's an investment. And when we look at those investments, part of the criticality is the fact that it's future-proof. It's able to cope with emerging technologies and therefore give it a long life. If it's got a long life, it's cost-effective. And if it has a long life, then we can also afford to invest in it properly. So I think, when we think about criticality, yes, people think about reliability, and that's incredibly important. But we also think about criticality in terms of the system's ability to be able to adapt to change and to emerging technologies. And so it's a two-pronged approach for us.
Okay, I want to drill a bit deeper into the technology in a minute, but you've certainly touched on a few future-proofing themes there. The industry talks a lot these days about open source technology that is both scalable and flexible. I mean, for me, future-proofing also means something that is well supported globally and will be well supported into the future. But just on the tech, can you give us a quick summary of where mine site technology is these days, with its technology development strategy and the deployment?
If you look back, you mentioned in your introduction about the PED system, and it made me smile with your analogy for the Morse code underground. And certainly, it's true to say that we've been focused right from the very early days around people. That was a passion that drove the development of PED with the ICCL. If you then look at that from a product perspective, we developed that then into the mine phone, which in form factor is like the old traditional sort of phone, which gave communications capability, voice communications capability underground, which is a technical challenge, and we brought it to that mine environment. And then if you move up to the sort of present day, then we have our smartphone, our smart Cortex phone. So if you look at it from that traditional sort of product development and rollout to the industry, we've been very successful with that, and we continue to do that. And then if you start to branch out from that Cortex phone, it's not just a functionality, but it's a connectivity issue, connectivity to LTE in this case, for example. So that's kind of like a sort of product development kind of approach. But if you think outside of that product-based approach to a solution-based approach, then it's a much kind of broader concept. And when you look at that, things like scalability become important. And when I talk about scalability, I'm talking about not just the physical size of the mine, but whatever the data density needs may be for particular areas in the mine, what are their particular sort of tracking needs, what's their voice intensity requirements. So scalability, when you start to think in terms of solution rather than product, becomes a much kind of broader subject. If you therefore look at that principle and look at the way we looked at the Axon infrastructure platform, it really was developed in exactly that way. So I mentioned the connectivity opportunities through PoE+, and we've embraced that technology to our wireless access points to give us that kind of flexibility. And that's innovative and it gives flexibility. But when you then look at the next stage and say, okay, there's life beyond, let's say, a wireless access point, we need to look at how we could provide for that. So our technology at the moment has definitely gone to edge devices. In other words, devices that sit on the edge of our platform and give us the capability to be future-proof, to be able to develop new applications, to be able to connect to emerging technologies and to platforms that don't even exist at the moment. So in terms of the scalability and the technology aspect of it, what this means really is for our customers is that they can take a platform which has this future capability, but very much size it and configure it for the needs of today. with the confidence that they know that if for future changes, this same platform will be able to scale up as they scale up. So it's a very sort of risk-free approach. In previous ways, when you think about just about technology and product, it's a big decision. Once you've got into bed with one technology, you then live with the consequences of that decision. And a lot of the time, that's great. But in today, when you look at the rate of change of technology and the emerging technologies, it's getting even harder to make a decision based on technology. So we've decided to make a different decision and create a platform that caters exactly for the technologies for today, but also gives us the capability to introduce technologies at different points in that platform as they emerge and as the minds embrace them. And it's the same approach with our software solutions. So when we look at software, it's just a tool. It's not a remote thing. It works in tandem with everything else that you have. So Helix, which is our new enterprise level software platform, which is the same way. It's modularly based. It takes all of the information and the benefits from the Axon platform, but customers are able to select the applications that they need for their mine. And as future needs and future functionality emerges, it's a constant ongoing development, then customers can choose to take that particular module and bolt it onto the platform, which allows them to expand. So again, it's a low risk. It means that people can invest the levels they need to invest at that time and be able to then expand on it or shrink it as required.
The whole concept of open source or agnostic, I think one of the things we've tried to do with our solution with Helix and Axon is also look at what kind of technologies are there on the shelf there today that we can bring into this platform and make sure works appropriately in the underground space. And what I mean by that is examples like Microsoft Azure. There's things in Azure that if you give it the right edge device, if you give it the right bandwidth, low latency bandwidth and connectivity, you can do AI on an edge device underground. You combine that with a geospatial aspect of what we do, and you can do some smart things underground. You can either do that on the edge device, you can do it on premises at the mine site as well. You can put it on a server, or you could put it in the cloud. So I think what's for me has changed here is that whole scalability, the adoption and use of off-the-shelf technologies that we didn't have in the 90s. We didn't have AI. That was a PhD concept that we couldn't apply, or we didn't have the computing power. Today, I think a lot of those things are much more readily available. And in Helix and Axon, we've tried to make sure that we can bring that all together, right, to deliver on this digitization dream that we have in the underground space.
If we consider the concepts of open, agnostic, and future-proofing for our hardware platforms, then we should think in the same way about our software solutions. MST has a history in software development. Over the last 10 years, we've developed our advanced tracking engine and network management packages, as well as 2D visualization packages to allow users to visualize this information. But until recently, it's fair to say that this software has really been focused on delivering a user interface for these functions. That's all changed with Helix. Helix is our next generation enterprise software package. It's cloud or on-premises based. It has a very modular approach, and it takes advantage of our existing IP. So it's compatible with previous generation infrastructure that also uses our software systems. But Helix is all new. It's based on a true geospatial mine coordinate system. So it speaks a common language with our customers. So areas such as planning and scheduling will be able to recognize locations in the mine based on a common system that they use. Helix has 3 new modules. So the first one being Helix 3D Connect. Helix 3D Connect allows you to visualize your whole mine. It's more than just a map. It allows you to configure views that are pertinent to you. So whether you have location or zone responsibility or interest, or whether whole mine from an equipment perspective or whole mine from a people perspective, then you can easily configure those views to give you exactly the information that you need around your mine at any one time. But in addition to this, we've also built in the capability to be able to connect to multiple mines at any one time. So if you're a supervisor with multiple mine responsibility, you can have all of these mines displayed in one place, and each one of those mines can be configured to show you the information which is important to you. In addition to this, Helix really does help us bring the Axon platform to life. So previously we've talked about the edge devices, the Axon control and the Axon gateway. Well, Helix Automation, the second package that we've launched, works with Axon control and gateway to bring you an automation capability. And this automation capability is as simple as Boolean logic. So in other words, simple logic statements can be written and activated through the Axon control, right through to geospatial information. So taking the information from our tracking engines and building this into more complex control schemes, such as ventilation on demand, for example. So in essence, we can monitor the number of people or equipment or combinations of those two things in a defined zone, and they take action such as turning on or off fans or increasing the number of fans for increased airflow. So it really does lift it above the simple sensor-driven control approach. Because we can get involved in this level of control now, it's clear that we'll have a need to be able to communicate with other systems in the mine. And so information from Helix Automation is made available through using MQTT to other systems. The third package that we've launched in the Helix family is Helix Sentinel. And Helix Sentinel really works well with our tracking equipment, our hardware, our people tags, our equipment tags, location tags, and also with our tracking engine. And Sentinel gives this information in a very familiar way. So we call it like an electronic version of a tag board. So it has that tag board feel when people look at it, but behind that simple tag board approach sits a powerful logic and rules engine, which allows you to lift the functionality of this to improve safety and personal well-being through the mine. So for example, it could be something as simple as somebody checked into that zone, but we haven't seen them in that zone for a period of time. So you may want to investigate that. It could be that there's an equipment failure. It could be that they've been interrupted on the way. It could be they've gone to a different zone. So it allows you to pick up those kind of things. But then from a well-being perspective, for example, if you have an area of the mine that somebody shouldn't spend more than a specific number of hours in, then this kind of logic is simply built in, and then you can have warnings when they need to start leaving the area, and also record how long they've been in there in a cumulative way. So these are the first three modules from the Helix package. But Helix is very much a platform designed for mining, and the applications will grow to take advantage of the information that we have from our digital network and as industry needs change. So the concept is the same. You can use as many or as few of the Helix modules as you want, pertinent to the mine's life cycle, what you really need at that time.
Given what's at stake in terms of people and their safety, and also returns on capital in mining, which of course is among the world's most capital-intensive industries, the cost of a lot of this technology seems to be pretty insignificant next to the cost of capital equipment and plant, and certainly its impact measured in utilisation and ultimately returns. Haydn, you mentioned partnering. These days, mining company chief technology officers, even chief executives need to be on top of technology trends and where they're taking the industry. it's accepted that they need to be making the right smart connections, whether that's for finance, exploration, insights, project development partners, etc., and then the right technology partners. Presumably, you don't just want to be a product supplier. Companies are out there building technology roadmaps and wanting to ensure that any digital transformation is going to stand up over time. You're working with a lot of mining companies on that mapping. What's Finesight Technologies' mission, and what does it bring to the table? What does this company bring to the table that makes it different in the marketplace?
Well, perhaps before I answer that, just a couple of points. I think when I was working at Rio Tinto, we had a number of relationships with some key vendors. You know, the company that first put in a GPS-based dispatch system was Wenco at US Borax. That was the first ever deployment of that. We worked with Maptech to look at short-term scheduling and life of mine planning. So we were working with quite a number of vendors at that time, and you know, I really saw from the ground up just how important it is to have a working relationship and a partnership with external vendors, and they really need insight from the end customer as to what their problems are and what they're trying to achieve. I certainly learned right there that that if you don't have a strong partnership and a working relationship and a common set of goals, that you're really going to take a long time. When I sat down to try to connect those two in the mid-90s, i.e. a short-term scheduling product from Maptech with a fleet management system from Wenco, you came across the problem that there was no concept of geospatial between the two. There was no way of tying this together, and I think there was a couple of things there. That's because we developed these technologies in isolation in a non-connected world where you don't track things in real time. So back in the 90s, that was sort of just developing. We just introduced GPS. We were just introducing, you know, some decent computing to be able to do some really complex algorithms on the scheduling, but there's no ability in real time to tie this together. And really, there wasn't really a conversation being had, I don't feel, at a senior level between technology vendors and customers, corporate customers. Now, I think you fast forward to today, and that's grown over time. That I think most vendors now do talk to corporate customers, and I think one of the things that set MST apart is that they early on started to talk to some key customers. So we have partnerships and deal with customers like Anglo American, BHP, Rio Tinto, Oceana Gold. So top tier miners, mid tier miners. You know, we do have a conversation. And I think what sets us apart is that we know that we have to share our roadmap and where we're thinking of going with things, along with sharing and looking at what the customers are doing. And I think it's a journey for both of us that we're taking. And it can't be just left to one or the other. You also have the OEMs in there. So I think there has to be this working relationship, even though sometimes we can be competitors. I think the challenge that we face to improve safety and productivity unites us in that, but there certainly has to be a transparent dialogue as best we can between all of us to make sure we're on the same roadmap, as it were, or the same general direction. And I think going back to your first question, that's got a lot better. And I think MST certainly takes that very seriously, that we have to sit down and have those relationships, share the roadmap with our customers. And I think what we see, you know, this has been a 30-some year journey for me to finally see mine planning connected to fleet management. And when you look at that in the underground perspective, also connected with the ability to track and do voice all on the same platform. You know, what I see in Helix is finally is this ability to deliver a solution that is geospatially connected in real time, that can track underground assets, and that can deliver on some of those promises that, you know, in the mid-90s I was hoping to achieve. So it's been a kind of a journey, but I think the truth is, I think what stands MST apart is that from the get-go, they were focused on solving underground problems. And the difference being, when I was at another company, say 10, 20 years ago, we were focused on solving problems in surface. When you had GPS, you had Wi-Fi, it was a lot easier to sort of solve. I think where MST really comes into its own, it's developed solutions for the underground. And I think the mistake is when you take a surface technology and try to shoehorn that into the underground and expect that you can just adapt it, it doesn't work. The underground is very unique. The challenges are unique. Whilst we have common goals, you have to be able to develop and design a system that will work into the underground space. And I think importantly for me, also take this whole geospatial aspect with a lot more seriousness and deliver on that. You could get away with not having that so well as part of the foundation in surface, but in underground, when you look at an underground mine, you need to visualize it in 3D. You need to be able to visualize it geospatially as it is in the underground space. You can't sit there in a dispatch tower and look over the side of the pit and see everything. So to me, what's been great to see at MST is this legacy that they have about focusing on the underground space and solving problems. I think in the last several years, we've really gone to work to deliver something that can bring together some of our legacy solutions with some of the newer solutions that we're adopting, some of these newer agnostic views on wireless, but also it's our people and those relationships and that dialogue, whether it be around roadmaps, whether it be our solution architects that are on site or our technicians solving problems, whether it be our R&D team or product managers that understand the challenges and are working with at a corporate level or a senior mine level with people to solve them. It's the relationships that really make this work. You know, if it wasn't for that, we'd be a commodity. You could go down to Radio Shack and buy it, right? You could buy a Nest thermostat and put it in the underground space. It doesn't work that way. And I think it's people that really come together to solve those problems. So I know that there's some people talk around, you know, there's a fear that we're taking people out of mining, people are going to lose jobs. I actually see the exact opposite of that. I actually think it's going to bring more people together in more meaningful work, in more productive relationships, because we'll focus on doing things that really will bring new lease of life to mines. And yes, we'll remove people out of harm's way and perhaps from machines, but the amount of upside there is to actually working with some of these solutions we're talking about, from AI to data analysis, you know, big data to just automating and adopting more smart sensors, I think is going to create a whole interesting future for a lot more people. And you know, the reality is mining's not going away. We just have to obviously adapt it and change it to these new technologies and solutions that we have out there. And I guess, you know, the people that, as I said before, that we're bringing into this industry expect that. They have that, you know, you take your children away on a vacation, they're pretty unimpressed if they don't have that 4G bandwidth connectivity. It's no different for people going underground. So we need to make sure that we supply our people that go into the underground mines with the right kind of technologies and solutions so they can be safer and more productive. And that's, you know, that's why we talk to our customers, not only about what they need today, but what they need in the future. 5 years from now, 10 years from now, we really look at that life of mine approach to this. And that's why we've created this platform that allows us to go on this journey together. And I know it's a journey of different rates or different paces. Not everybody will put in a 4G solution across the whole mine. Some people may adopt Wi-Fi 6. Some people may still want to use Bluetooth or LoRa. Some people may want to use certain aspects of AI and not others. So I think it's a journey of a different paces and different needs. And we're certainly there for the long run. That's what we've been in this space for 30 years, and we will certainly continue to focus on that. And I guess the key is to have that relationship with our customers and those corporate miners, which is most important. And for me, the call to action is that even if you're not one of our customers, we certainly want to talk to you. I think, you know, we started out in this business 30 years ago, putting a solution in place that I hope has saved miners' lives. we still want to have that dialogue. Even if you're not a customer, we would like to sit down with all miners out there, all corporates, all miners, and sort of have that open and honest, transparent dialogue about how we can go on this journey, because digital transformation is what we need to be focused on and deliver on to improve safety and productivity.
Okay, gentlemen, I think we've covered a fair bit of ground there. We're certainly seeing a significant shift in focus in the industry and a big shift in capability on the supply side. I'd like to thank Haydn Roberts, the CEO of MineSight Technologies, Mark Palmer, the company's GM for product management and marketing. Thanks to the audience for tuning in. As Haydn mentioned, if you've got questions for Haydn or Mark, or you would like to talk to them about your technology roadmap, please see the contact details on the slide at the end of this presentation. We look forward to continuing this conversation. Thank you all, and goodbye for now.